Hey guys, like I said, I've been asked to do a Calc 3 review, so I'm going to cover sort of briefly what I think are going to be some big topics that you should know for 272. Now none of these, standing in front of the topics. So I'll be doing different videos for all of these topics, so if you're good with one, feel free to skip to the ones that you need a refresher with. I don't think any of these will be too difficult, and I'm just going to go through the basics of them for each one. So first one is partial derivatives. And so the idea of a partial derivative is if you have a function that depends on more than one variable, if you want to take the derivative with respect to a particular variable. For example, let's say we have like a function of height. And height is a function of x and y, and it is given by x times y plus y squared. So let's just say we're on some specific hill where it has a height given by that. And let's say we want to know how the height changes as we move in the x direction. So what we would do for that is we would take what's called a partial derivative of the height with respect to x. So this tells us how it changes as we move in the x direction. Now when we do this, what we can do is we can say, alright, y is going to stay constant, so we can just treat all the y's like they're constant and treat x like it's the only variable. So if all the y's were just replaced with constant numbers and we wanted to take the derivative, we just take the derivative of this component right here and we would just get y. The same way we could take the derivative of height with respect to y. So this tells us how the height would change as we go in the y direction. We can see if we do that, x is just going to be treated as a constant. So if we take the derivative of this first part, we would just get x. Then the derivative of the second part give us plus 2y. So I hope that this makes partial derivatives seem a little bit easier. And of course, if you have 3, 4 more variables, you just treat it the same way, where the variable of question you treat as a variable and everything else you treat as a constant. I guess one more quick thing that I could do is sometimes you'll get something where it will be like where that can seem a little bit daunting. But what that means is we take the derivative of h with respect to y, and then we take the derivative with respect to y again. So in this case, we would take the derivative with respect to y of x plus 2y. I'm probably standing in front of the board. So you can see if we're taking the double derivative with respect to y, you You just take the derivative with respect to y twice. We knew this from before. We'd already found the derivative with respect to y. And this would just give us 2. Alright, so I hope this clears some things up. I think that's going to be it for the partial derivative video.